It's time to make some noise. Because today we're going to talk about noise pollution and acid rain, but that comes a little bit later. So, noise pollution sounds like a silly thing, but it's totally legitimate. If you don't believe me, go into the other room, find someone in the house, and scream as loud as you can in their ear and see if they respond. I guarantee you they will. Just don't tell them that I told you to do that. So noise pollution is when there is sound at a high enough level that it's going to cause physical damage to an organism, perhaps their hearing, or it could cause psychological damage or stress or anxiety. And that's a pretty serious thing. It can have some significant impacts. I'm very sensitive to sound myself. Many sources of sound in today's world: transportation of cars and planes, construction. They're building a car dealership down the street from my house, and they use a jackhammer all night. It's very, very annoying. I can never fall asleep. Anyway, but also stuff that's just going on around the house and down the street, and the shops that you do, over at the mechanics using the drill, that's pretty loud, So all sorts of stuff can contribute to noise pollution, especially in urban areas. There are significant impacts for humans, the biggest one being hearing loss, right? The National Institute of Health reports that if you're exposed to sound over 85 decibels for even a few minutes at a time, you can have significant irreversible hearing loss. Reason for that is because you've got these bones in your ear, the malleus, incus, and the stapes, that vibrate when you hear sound, and your brain turns that into information that you can actually process. But if these bones get damaged due to the sound being too loud and then vibrating too quickly, it's irreversible. 85 decibels is not that loud. A lawnmower is louder than that. And it goes chainsaw, remote control plane. I'm sure you guys are using those all the time. Music from your car stereo, guns and planes, but then finally a concert. Those are really, really loud, and if you're exposed to any of these noises for extended periods of time, I'm talking, hours, but in most cases minutes, it can damage your hearing permanently. So be careful about that, especially with earbuds. Here's another graph showing basically the same thing. Here's the threshold, 85 decibels. Lots of things in our daily life are over that, including a blender. This isn't part of the curriculum, but earbuds can significantly increase the chance of getting hearing damage because they're inserted directly into your ear. I use them. Everybody uses them, but I just want to let you know that just to be a little bit more thoughtful about the way you use them, because you can have it high volumes. If you're mowing the lawn and you've got the music on, it can do damage in as little as 8 minutes. So just be aware of that. Cool fact alert. The loudest sound ever recorded in the world was the Krakatoa volcanic eruption in the late 1800s. It ruptured eardrums of people 40 miles away. It was clearly heard thousands of miles away, and it traveled around the world 4 times. Totally wild. Wish I could have been there, but also not at all. It's not just hearing loss. It can have cognitive impacts on your brain development, especially as young infants and their ability to develop language skills. It can raise your blood pressure. It can lead to stress, anxiety. It can actually lead to depression as well. I know I get very frustrated when there is like a consistent sound of someone's leaf blowing next door nonstop. But there are also significant impacts on organisms. Think about how organisms rely on sound. Birds communicate with song with one another. Frogs use mating calls every night. Dolphins echolocate. Bats echolocate to get around and see. So if there's too much sound, that's going to impact their abilities to do those things. It can raise stress levels in organisms, which can change their behavioral patterns and also their hormonal balances. It can mask the sounds they use to communicate, whether through mating or through hunting, or even just communicating with one another. It can damage their hearing, which is just not great across the board. It can change their migratory routes, especially for marine mammals like whales that communicate over hundreds of miles throughout the ocean. If there's too much propellers and boats and stuff, it's going to be difficult for them to do that. Here's a picture showing marine mammals like whales and dolphins and porpoises and stuff use echolocation and to see and move around, but they also communicate through their whale noises, like that travels very long distances, and with all the propellers and the radar that we use in your boats and everything, it can make it very difficult for these marine mammals to hear. I mean, imagine trying to communicate with someone on the other side of the room, except everybody between you is screaming at the top of their lungs. It's not going to be easy. I mean, it's a very hot topic in today's world that the number of boats is disrupting migratory and mating patterns of marine mammals. It's not a new thing, but it is kind of sad. Okay, that's pretty much it for noise pollution. So if you have questions on that, write them down, bring them to class. Let's get into acid rain, acid deposition, acid precipitation. It's all the same thing. We've talked about it before a little bit when we talked about soil formation and chemical weathering and erosion. But I want to talk about it in more detail now. First of all, acid rain is kind of a misnomer because it could be rain, but it could also be snow, sleet, hail, fog, mist. All those things can be acidic. And acid rain this is the simplest way you could summarize acid rain formation. Sulfur dioxides and nitrous oxides from burning fossil fuels releases into the air, reacts with the water in the air, and forms acid precipitation. That's pretty simple, and it's about as simple as you need to get. But let's break it down a little bit more, right? So when I say nitrogen oxides that I've got here, NOx, what are we talking about? NO, N2O, and NO2. That shouldn't be new news. Sulfur dioxide, same thing, SO2 and SO. What are the sources of these? You can probably get 3 out of 4 of them, right? Natural sources of nitrogen oxides include not nitrogen fixing bacteria, but denitrifying bacteria, and lightning. Sulfur dioxides really only come from volcanoes. Meanwhile, anthropogenic sources of these, it's pretty straightforward, and you can probably already know what it is. In fact, you should. Nitrogen oxides come from burning of fossil fuels, motor vehicles, and coal-burning power plants. Sulfur dioxides really only come from coal-burning power plants, although it does come from burning diesel fuel, although not gasoline, just diesel. Here's a little bit more detailed photo describing how acid rain forms. Those sulfur dioxides and nitrous oxides are released into the air as primary pollutants, directly released into the atmosphere. They react with water and oxygen through a chemical reaction in the air, forming the secondary pollutants, sulfuric acid and nitric acid, which then rain down or snow down or mist or fog down or whatever. And if you notice, the wind is carrying these pollutants very far away from where they originated. The acid rain is not at the source of the pollutants. So it's important to remember that the communities that are downwind of these power plants are the ones that are most at risk. And in many cases, the communities that are producing these pollutants aren't even having to face the environmental costs or the health costs. Here are some areas around the world. Yellow dots are most affected by acid rain currently. These are highly populated areas with large uses of coal. Meanwhile, green dots are areas that are somewhat affected, and blue dots are areas that are probably going to be affected in the future. Japan's a blue dot because they switched to coal after the Fukushima accident, and they built 14 new power plants, I believe, in the last year or so. Okay, so what is the big deal with acid rain? There are harmful impacts for both ecosystems and humans. It doesn't actually have any, like if it lands on your skin, it's not going to hurt you. I wouldn't recommend drinking it, but it doesn't have any direct health impacts on humans, but it does for organisms. For humans, it can damage our stone structures, whether it's limestone or marble or granite, right? If we've got statues or obelisks or whatever, acid rain can slowly erode and break them down, which is, damage of cultural heritage, which is not a great thing. But the impacts on ecosystems are far, far greater. And for this, we got to call back to ecological tolerance from Unit 2, the range of abiotic conditions in which an organism can survive. And if you look at this graph, it shows the aquatic organisms and sort of the level of pH at which they start to have issues. So anything more acidic than a 6 for a snail is going to have issues for the snail and for the clams. Anything more acidic than 5.5 is going to have issues for the bass, the crayfish, and the mayfly. Frogs are pretty resilient to acid. They can go down to 4 pH, but anything below that, and they're going to struggle. It's not just aquatic ecosystems, though. It is lakes and rivers, but it can also impact soils and forests. And one of the ways it can impact those terrestrial biomes is that the acidic water from the acid rain pulls aluminum out of the soil, and that can do a couple of things. First of all, it can directly damage the tissue of the plants and animals because it's heavy metal, can lead to bone and brain disorders. It can run off into surface water, so it doesn't always stay in the soil. But ultimately, it makes it harder for the plant's roots to absorb water, which is not great because plants need water to live. Acid rain can also prevent not only organisms from thriving, but it also can prevent them from reproducing. Many eggs of amphibians and reptiles are permeable and sensitive to changes in pH. So even if the organism can survive in the low pH, maybe its eggs cannot. It can also directly lead to death, the acid can. It can damage the tissue of plants and leaves and trees, which can weaken them in terms of their ability to be bounce back from diseases and be resilient to natural disasters. It can leach nutrients out of the soil. That's related to the aluminum. Not only does aluminum make it harder for plants to take up water, but also nutrients like nitrogen and sulfur and phosphorus. And also, it can lead to some serious trophic cascades. Right? Imagine this frog eats a mayfly, and the pH in this aquatic system drops down to a 4.5. The frog is fine. He doesn't care. But the mayfly is struggling, and the mayfly might actually die. But if the frog eats the mayfly, the frog has now lost its food source, and so the frog is going to start to struggle. And that's a trophic cascade. We talked about that way back in Unit 1, but that can have long-term sort of domino effect impacts on ecosystems. It's important for you to note that the impacts of acid rain depend on where you are and the geologic history of that area. If the bedrock and the soil in that area has a lot of limestone, it's going to reduce the impacts of acid rain. Here's a picture of limestone that I took today. I totally didn't Photoshop it, so don't you dare try to call me out. Limestone is used to create lime, which you may remember you can spread in your garden to reduce the acidity. But calcium carbonate is also the chemical formula. It can neutralize the acid rain's impacts. Take a look at this diagram. Acid rain is falling down onto this ecosystem. Some of these acidic substances can react with aluminum to release, or some minerals to release aluminum, which we just talked about, why it's not so great. Those sulfur compounds can also directly be released into the lake, which can damage the organs and the reproductive ability of these organisms. Or if these acids react with limestone, instead it's going to produce harmless inert substances like calcium and magnesium, totally neutralizing the effects of acid rain. Here's a map demonstrating the distribution of limestone around the world. So you can see where some areas, like say the Amazon rainforest, might be more at risk to acid rain because they don't have limestone geological history, where some place like southern China has more limestone, might be able to weather those effects a little bit better. So what can we do about acid rain? We've talked about the cap and trade that the Clean Air Act imposed in 1990 that limited the amount of SO2 that companies and factories can emit. And as you can see, over the past couple decades, it's dropped from about 16 million tons of SO2 per year down to about 5. So it's over a 300% decrease in SO2 emissions, which has had amazing impacts on the acid precipitation. Take a look at this map of the United States. We've seen this before a couple months ago. Very acidic orange precipitation in the east coast of the United States in 1990. But thanks to that cap and trade, by 2014, much less acidic, right? Much more green, much less orange. So a lot more neutral precipitation overall. You might be wondering why the East Coast so acidic. Where is the coal in the United States again? That's right, Dora the Explorer. It's in the Appalachian regions right here. So that's where all the coal is found, or most of it anyway, and that's where most of it is burned. There's also more people on the East Coast. So great success with that cap and trade program, reducing the impacts of acid rain. But how did these companies actually get the bar from up here to down here? What did they actually do? And for that, they need some technology that they can install in their power plants. The first of which is called a wet scrubber. And the wet scrubber basically uses chemical treatments to remove pollutants from the gas. So imagine we're in a power plant. Well, we are in a power plant, but imagine we're in a coal-burning power plant. The coal is down here. We're burning the coal. Here's the fire that's burning from the coal, and we're heating the water in these pipes, which turns to steam, turns a turbine turns a generator, electricity, yay. But what about all these emissions from this combustion reaction, the CO2, the particulate matter, the sulfur? Well, it's going to go down this chamber here, this flue, and it's going to go into what's called a wet scrubber. And as this gas rises, it's going to come into contact with these liquid that is being sprayed down. And that liquid has calcium in it and water. And that will help neutralize the impacts of the acid and actually basically simulate acid rain formation inside a tank, capturing the acid rain, quote unquote, and recycling it, reprocessing it, or even disposing of it safely. So rather than all this SO2 being released out into the atmosphere out of the smokestack, it's instead captured by this chemical cocktail and cleaned. So the smoke that's coming out of these smokestacks is mostly water vapor and CO2, not a lot of SO2, and not a lot of particulates. Let me charge my computer. Ugh. Come on, here we go. So that's a wet scrubber. Here's another picture. This one's from your book. The dirty gas comes in. The SO2 in the air comes into contact with the scrubbing fluid, and that gas gets, quote-unquote, scrubbed. All the air pollutants get brought to the bottom in this toxic water, which can then be reprocessed, cleansed, or disposed of, and the air that is released is much, much cleaner. So that helps reduce the SO2 emissions and reduce acid rain. Additionally, there's a little something called fluidized bed combustion. And this looks complicated, but it's not too bad. Basically, what they do is they burn coal and limestone together, and they do it in pure oxygen. So if you remember, combustion requires oxygen in order to burn. So if you inject pure oxygen in to the area where you're burning coal, that reaction is going to burn a lot more efficiently and a lot more intensely. And that does a couple of things. One, it's going to increase the concentration of pollutants that are produced. So if you've got combustion happening that's more efficient in this area, the gases that are produced are going to be more concentrated, and it makes it easier for them to be captured. Additionally, you've got limestone in there too. You've got a bed of limestone, which is going to help capture some of those emissions, some of those pollutants, the NOx, and some of the sulfur dioxide as well. It's going to help capture some of those before they can escape, because the limestone, again, is alkaline. It's basic, and it will react with these to neutralize the acid. So that's fluidized bed combustion, and that's pretty much it. So if you have questions, please write them down and bring them to class. I'll see you next time.